Calculate enthalpy for the following reaction. So we have an equation over here that we need to get from manipulating these three equations on the right, and this is a Hess's Law problem. So basically we can flip these equations if needed, or we can multiply them to get different coefficients. So it's kind of like a puzzle. You just have to play around and see how you can take these three equations and get them into one equation here on the left. So the first thing that I normally do is I look and see what side each of these molecules are on and see if I need to flip anything. So looking at this first equation right here, C2H2 is a reactant, and in the equation we're trying to get, it's a product. So we are going to flip this equation, and they both have a coefficient of 1, so we don't need to multiply it by anything other than -1. So multiplying by -1 will flip it, and it'll also change the sign of our delta H value because that is also affected when we multiply the reaction by something. So I'm going to rewrite it down here, and it'll be 2CO2 plus H2O. And then on the product side, we have C2H2 and 5/2 O2. Okay, so now let's look at the second one. We have carbon on the reactant side, which is what we want it to be on because carbon is a reactant in the main equation too. But there's a 2 in front of it. So I think the best thing to do would be to multiply this whole reaction by +2. We don't need to flip it or anything because carbon's already on the right side, but we want a 2 in front of it. So all of these terms are going to get multiplied by 2, including the delta H value. So doing that, we have 2 carbon plus 2 O2 going to 2 CO2. And then I'm going to rewrite our delta H value down here too, which I forgot to do for the first one. But multiplying this by 2, it'll be -787 kilojoules. And for the first delta H, we just flip the sign, so it's positive 1,299.5 kilojoules. And then for our last equation, we have H2 on the reactant side, which is also where it is in this equation. And it doesn't really look like we need to do anything else. So I'm just going to rewrite this equation down here, and then we'll see if we need to modify anything. And then this delta H value is just the same as it is up there. So now we're going to see if things can cancel out because we obviously need to condense all of these into one. So things will cancel out if they are on opposite sides of the equation, so like products and reactants. And if they have the same coefficients, they'll completely cancel out. If they have different coefficients, you cancel out the smallest one and subtract that from the biggest one. And that's the biggest one will have some leftover. But let's start with the CO2. We have 2 of them on the reactant side, and we have 2 on the product side in the second equation. So those will cancel out. Next, we have water as a reactant, and we see we have water as a product down here in the third equation, so those also cancel out. We have C2H2 on the product side with the right coefficient, so that's going to stay right there. We'll come back to the oxygen, and then on the second equation, we have 2 carbons on the reactant side, which is good. And same in the third equation, we have our H2 as a reactant also. So now we're just left with the O2s. So we have 5/2 on the product side, and then we have 2 on the reactant side of the second one and 1/2 as a reactant in the third one. So what you can do is you can combine these two and then see if it'll reduce with the products one. So we have 2 plus 1/2, and you can also think of the 2 as 4/2, So adding these two together, we have 5/2, and that's exactly what we have up here. So the oxygens fully cancel out, and so we canceled out everything except what is in the equation we want. So that means what we did worked. So I'm just going to rewrite it again. 2C plus H2 goes to C2H2. And then what we're solving for is delta H. So to do that, to get delta H of the reaction, we just have to add together all of our delta H values, the modified delta H values. So 1,299.5 minus 787 minus 285.8 gets you a delta H of reaction equaling positive 226.7 kilojoules.